So what I would like to talk about today is that something which is very simple when you look at outside, it's quite complex when inside. So I would like to inform you today about how DC works, and I would like to give you certain insights and certain information how you can prevent certain problems. Specifically, so I'm going to share today insight about DC replication, what problems you can have there, what problems you possibly can have in the replication and indexing specifically, and the last part is that how to deal with scale and what advices or what gotchas you might have while scaling your application. And before we go into these details about how things work, I would like to step back and give you perspective why this is important for somebody who we all care today, right? It's end users. And this is the feedback from unhappy Jira end user. Nodes are showing different data for same project and the same board. Right? I'm using Jira as a source of truth, and I believe a lot of people show how many people using Jira as a daily source of truth. Right? Awesome. And when it lies to you, it's confusing. It's like it's not the same product anymore. It's just a set of applications kind of sitting together. It's super confusing. So the problem if thing doesn't work, this is what is going to happen. What specifically I would like to talk today is that I would like to explain why this problem is important on the bigger scale, what is causing those, overview of how Jira indexing works on single node. That's the first part. Then how Unix replication works in data center, how this whole magic happening behind the scenes. Then we'll talk about when things doesn't work as expected, when they're broken. And then as part of that, I'll share a couple of examples and a couple of problems. So let's start. What is important about this discussion and about this is that expectation itself is come from the promise which we as a company, as Atlassian, and you as a vendor delivering the application are giving to our clients that they want to have better service. And that comes as the high availability, because DC is a high availability. They want to make sure if one node goes down, everything is fine. That's one. Second one is that they want stability, including consistency. They don't want to have just set of something running somewhere. They want to understand that this is the whole thing is important and sets and acts as a single source of truth. And the last part, which is a combination of those, is their performance. The stability together with the performance, so more users can use the application, and it scales as the company grows. So this is allowing them to grow the business, because at the end, Jira is just a source for growing the business for somebody which uses the Jira, for NASA, for Uber, and they want to use Jira DC to make sure it's working for them and scales together with their business. Unfortunately, and this is where my team came into play, is that things doesn't work for them. So previous support here is giving a hand, helping them to grow and overcome those problems. And that's why we anecdotally have a lot of feedbacks about problems, how things is not working well. We know how they should be working. And as part of the premier support team, just a brief explanation who we are, what we do. We have quite aggressive SLAs. It's half an hour for L1 when system is down. And it's 2 hours for L2. That means level 2 tickets when it's a huge performance degradation. It's a quite tight time when we need to make sure that the application will be up and running after that. And sometimes the downtime caused by apps. That's why basically the call of the discussion. And how do you know if it's a problem? Well, build the company which is data-driven. We measure everything. And then we track those problems as L1, L2, level 1 or level 2 tickets. It's a metrics inside the company. So we measure how many of those L1, L2 tickets caused by different areas. So the level 1 and level 2 means application down or serious performance degradation, to the point application is not available anymore, or that it's not a node, but just a set of group of applications, kind of that. And unfortunately, from the data which we have, we know that apps playing significant role there, and the customer paying performance caused by sometimes heavy problems with that. And this is not only about these numbers. It's not only about this L1, L2 metrics, and then somebody is thinking about that. It's more than that. So there's a Jira admin perception and end users perception. Well, they have this problem. And then, first of all, it's hours spent on troubleshooting. So those hours you can do something else. It will be way better spent. And it also means money. Second thing is the confusion. Right? Is it working? Is it not working? I just run the indexing. What's going on there? And this is kind of erodes the trust. And as a consequence of those, you lose the confidence. OK, I just installed that. I don't want to touch this anymore. Just keep it like that. Install a new app? No, don't ask me even doing this. New custom fields coming from somewhere? No, I don't want to do this. So this is kind of no experiment, no trust anymore. The environment is quite stable. And freeze it. I don't want to hear anything about that. So that's something which is also doesn't help business to grow. Ben mentioned a couple of things we would like to change to the program, having more strict information. This is something which helps us and helps you also to have better trust, to make sure that the customers have more experimentation with the apps and they are willing to do something with the apps more freely. And then they're going to use them. So that was the why it's important, kind of more business context. Let's talk about how these things really works. Really, really high-level overview. If you have no idea what this is about, and then basically just walked in here randomly, is that Lucene in 10 seconds is this. That's a magic about Lucene. So you use something which is that in part of the UI, and this is how you see Lucene. Right? That's in 10 seconds. We'll spend the next 10 minutes talking about that. So you use this form, and then you touch Lucene. Specifically, Jira indexes. It's a Lucene. It's an open source library, which is in process. It's part of the Jira, and it creates documents on the disk and maintain those documents and make sure that it's consistent, making sure that it creates those documents. So it's a lot of data which is structured specifically in the per node itself on the disk itself. So it's not part of the database. And part of this is part of the memory. Second part is the GQL search. So we created DSL, which converts this nice abstracted language, assignee field, issue, all these kind of things, into the low-level abstractions from Lucene. So this way, you don't need to know the details about Lucene. It's fine. It's magic for you. But the beauty of that is that it's quite extendable. You create your own custom field function. You can create your own implementation, which helps you to extend the language. And the last part, which is a more user-facing part, is based on the GQL search, you have filters. That's something you consume it as the digestible data. These filters form dashboards. Then you have dashboards which you have even more complicated data. Or you can use agile boards. And a lot of developers using agile boards for daily work. That means they still use the GQL behind the scenes. And you can think about this whole as a pyramid. So at the top, something you as a user use. And at the bottom is Lucene. It's a foundation. It's a foundation of a lot of things which happens and drives all this vehicle. Let's talk about this foundation more in detail. So how exactly it works? Normally, Jira just talks to database for operations, for storing the data, and database is a source of truth. Fine. So when you do Jira indexing, Jira loads data from database. This is high-level overview for now. It creates the Lucene documents, and it asks Lucene to store those documents on the disk. And documents are a collection of the fields which we put inside the document. And Lucene itself stores those documents in the segments and collects those documents in the segments. And when you create new document, it aggregates those documents and creates new segments. Why it's important? Because those segments will take extra space sometimes, and that's why it might grow over time. So when you use GQL, this magic converts into the Lucene structure, and then you read those documents from segments, through fields, from the disk. And this is aggressive memory caching, so make sure that it doesn't cause too much I/O on the disk. Let's zoom in. Let's zoom in on the part which talks about docs and specifically how we store data on the file system. Each Lucene document will be produced by the issue. So issue might produce one or many Lucene documents. So in this example, you have issue. You have all associated custom fields. All together, they kind of create one abstraction. And then outcome of that, you can create one or many different documents. And in this case, it's an issue document. Potentially, you can create comment document. Potentially, you can create modification document or transition document or any other document which you want, and that will go to different Lucene databases on the disk. Again, something important to mention here, one issue, one document. If we look how exactly it works even more in detail, that will be important to mention it. So since it's one issue, one document, when you want to modify the issue, you can't update this document anymore. That means you need to find the existing document. So you creating the issue or updating the issue. In case of creation, it's kind of logical. But in case of you updating the issue, you found the existing document and just destroyed it. Now you're going to create a new document. So you create the blank one with the data. Now you're going to ask all custom field providers for the get values. And this part where the plugins are get involved. This is the part which very important to understand that all the plugin vendors will be touched as long as they will be called. Right? So if you're slow, that this process is slow. And later, as outcome of that, Jira will produce the document, and it might just index the document with the fields, or it might store also the data itself together with the field. And here you have option, if you don't need to store the value because you don't going to load the value, just you can save time and space. And the data will be stored on disk. So it's kind of zoom in situation of the previous high level picture. Looking at this, we already can see that there are a couple of things can be fast and slow. And we'll talk about problems later, but this is kind of checkpoint at this stage to see what we can learn, what data which we have. So looking at the fast, if you create the custom field or update the custom field, and then since it's going to talk all the custom field values, each time when the update document is updated, that means if you have a global scope of this custom field, that means the custom field code will be called even there is no need for that. Right? That means you modify one issue in project A, and then it's nothing to do with project B, and all the computation will be still going on. So that's why making the project scope for custom field will be way faster. Jira will not talk to the code which is not required to talk. That's one. Second one is that we create document each time when we do any issue modification. That means you touch or just transition the issue. Transition the issue, changing the status. You don't need to modify anything from the business perspective, but then we recreate the document, so we are going to recompute and recall all the custom field functions. That means if you do recomputing your values and not storing the values, you're going to spend the CPU redoing the job again, even though there's no need to do it. Right? Storing the values in this case, way better, because you avoid that. Another example is sometimes you want to show something, but you don't want to have a GQL search. You don't want to have the filters on that. None of that is required. So having the custom field being computed for indexing is just a waste of time. Jira will do the work which you don't care. User doesn't care. So the cheapest way is just to don't do this work. And you change the configuration of the custom field, and you say indexer is none, and that's it. You will be only visible for UI, but you will be not searchable, but it's fine. You don't need this. And the last part is more complicated, is sometimes you have dependencies for the custom field computation. So, and that has a trickle-down effect. You start computing, and then you start computing something else, and then computing something else. So having the details for those stops this massive, God bless you, stop this massive computation at a certain point in time. And it's way cheaper. So that was the single node. Let's see how we propagate these changes between the nodes. Let's see how it works in DC environment. So for DC, first of all, each node has its own Lucene copy. There's no single copy which is master. Each node has its own Lucene copy. Second thing is that replicating of the issues happens as abstraction of the issue and the action. We'll talk about this more details later, but it's important that it doesn't replicate the values itself. It's just saying this is something happened, take care about that. And the last part is it's eventually consistent by design. Each node replicates the queue in its own tempo. So it's each node doing their own things in its own time. And here, like a lot of people are saying, oh, eventually we don't need to do anything. And this is something which is a conventional wisdom. Everything is going to be all right, maybe not today, but eventually. It's not working very well for DC. And this is not working very well for our clients because that's confusing. Right? It's not the same cluster anymore. So I understand that this is the trade-off, because eventuality gives us a way to have a performance, but at the same time, performance shouldn't come at the cost of the stability and the consistency. So trade-off is important here. So getting back to how this replication is working, how we make sure that we keep this balance. So this part we know, like this is a single node. Jira issue creates Lucene document. That happens on the node 1. So node 1 keeps that, remembers that, and put a tag in database. Now node 2 reads this tag from the database and like, oh, OK, apparently you did something. Let me redo the work. And it creates the new document again. And this way, the issues get updated between the nodes. So this is the abstraction mechanism between that. Let's zoom in on this part. So there's a constant replication queue of events. So each node creates its own events in the replication queue. They all put the messages. Like node 1 put message 1, node 2 put message 2, node 3 put message 3. This is the replication queue of all events. And then each node, in its own tempo, reading those events from the queue. So in this case, node 1 reading from the events from node 2. And as you can see, node 1 is a little behind other nodes. So here, node 1 is having more trouble replicating those. And the node 2, node 3 events from node 1. So you're going to skip events which come from you. You don't need that. What is important to mention is that this replication queue and replication reading happens in the single thread. That means the many of modification come from one single thread, which happens in the single node. A couple of important tables and the data which you will be helpful for you to troubleshoot or just help you to understand how it works. So there is the queue stores inside the RIO. It's not the same RIO. It's just a table. Replication and index. So this is log entries, and we'll share details about these log entries later. Then node index counter. This is the position of those queue. So we know who is reading what and where. And two other tables is cluster node, the status of the cluster, and the heartbeat is the checks how periodically, and then it knows that nodes are alive. These two things help us to cluster together. So RIO table. This is example of the record. Here, and I make it vertical because it's quite a long record. So ID is the operation itself, and we'll keep this ID as a position in time. Index time when event happens. Node ID is the node which initiates those events. So the node 1 here is saying, I'm doing something with issue, and the operation is update. So it's asking all other nodes to update the issue with all related information. So it will have a cascading effect. And the affected ID is the ID issue of this event. So this way, node 1 tells everybody, hey guys, I updated the issue. This is the issue ID. Please do the same. So this way, everybody is keeping in sync. This is example of another replication event. Here, it's happened something different. Is here node 2 suddenly decided to have full index. The affected index is all, and say, hey guys, I just have a fresh baked index. It's nice, and please use it. It's very handy that you can use it. So, and it tells that it's full indexing event. And this is the file name. So this way, all the nodes can grab this file name from the shared file system, which is NFS or AFS or SMB, grab this file, and then this way they can have up-to-date index while they need this. So this is the way nodes are replicating full events between each other if they stuck or they can't replicate the queue, because sometimes queue will be completely truncated, or if the node never joins the cluster. So node index counter is the position of the operation. So here node 1 knows the position against node 2. Node 2 knows the position against node 1. And also they keep position against themselves just to make sure that they can skip their own replication events. And node table is information about nodes in the cluster. So you have status of the node, location, port, information when the node joined the cluster, and build version of Jira. And the second table is the heartbeat. So every node periodically updates this table with its own timestamp and the database timestamp. And if the timestamp is different, then it means there's a problem that database is way different than the node, which means it is a problem with the time in some way, or the node is too far away from each other. So this is important to see if the cluster is still alive, and these nodes are lost from the cluster. Quick catch up and recap on what we just learned is that the problem which we just talked about, single node, as you can see, just amplified between the nodes. So if you have a global scope, now each of the node will gonna have global scope for the same computation. That means if you're inefficient at that level, you're gonna be inefficient level later. Same goes for storing the values. If you are recomputing the value, in this case, you're gonna recompute the value at each node. So imagine you modify the issue once, and then you have 4 nodes, and suddenly you've modified the same issue 4 times, and each node, and you have 1,000 custom fields. You just waste 4,000 custom field operations, just for nothing. Same goes with the indexing. If you don't need it, don't use it. And the cascading dependencies, in case of data center, gets even harder because now you have a problem that each node recomputes something, and they update the data from other nodes. So you have a kind of storm of events happening between the nodes. So we talked how things works. Let's talk how things doesn't work. And that's sometimes it's even more interesting because when it's working, it's kind of boring, right? So I would say there are 4 typical areas when things doesn't work. So first one is it's slow at the node level, not at the cluster level. And that's a foundation because we know that each node will compute the data. That's why being slow here, that means there will be slow problems later. So these are 2 large groups, unnecessary computation and slow computation. So unnecessary computation, again, I keep emphasizing the same message over and over again because it's very important. The global scope is not mother of evils, but quite bad. And reducing the scope is way to reduce the complexity. And recomputing the value without modification is another one, when you just recompute the values even though there's no need for that. We just covered that. So for slow computation, the cascading computation is the one I mentioned. And another one, which I would say less obvious, and very often it's hidden. So you have custom field which reads data from maybe from another table, or from another database, or from another third-party provider. And normally everything works fine. No problem at all. Like maybe 20 millisecond extra delay. Things fine. Suddenly, this third-party thing starts being a bit slow. And then suddenly, issue creation takes 30 seconds. Why? Because this custom field was global. Right? Who would think? This is project A, this is the custom field which used project B, nobody uses this. Right? You would not find this correlation there. Or suddenly the issue transition becomes super slow. Again, 30 seconds, and there's no specific need for that. Right? This is something I would say we need to be careful and maybe have the short circuits there or specific logging to make it visible and explicit what's going on there and why the slowness is coming there. So a couple of advices is that project scope. I hope you remember that till that point. Storing values if it's possible. I know that it's not always possible to store the values, but if you believe that values will not change that actively, then store the values will be the best way. Avoid indexing for view-only custom fields. Something which I think a lot of people are feeling that reindexing is for free. So don't abuse reindexing because you can call reindexing from your own code. And that makes a cascading effect. Imagine everybody will, like each of the plugins will ask for extra reindexing. With all the complexity, it starts having the cascading effect. Sometimes you see 10 reindexes happening during the issue creation. Just because all the provider believes that they need to reindex also, and they ask issue to be reindexed. So at the end, you have 10 reindexes on that. And the last part is, this related to the announcement which we did today about the performance toolkit, please test on legit data sets. Why it's important? Because when you have 1 million issue, the size of Lucene become significant to start feeling problems on the small instances. Like it start having the problem with the disk writes. The cache will be way bigger. The JVM memory usage will be way bigger for you when you have small instances. You start feeling the problems when you start updating those issues in those Lucenes. If the data set is small, most probably you're reading from cache. You don't read it from disk at that point. So bigger Lucene, you start feeling more of the problems which is actually end users are having. So moving on for slow computation in between the nodes, and this is the tests which we had for scalability of the cluster. This is the same data which Ben also showing before. Is that, and that's the driver of the results for asking to have the reindexing, is that the time of creating the issue per cluster, and this is 10-node cluster, depends on the time of how much document was created, how much time spent document was created. So if you spend 800 milliseconds on creating the document, this is logarithmic scale, by the way, then the time decreases 20 times. So that means the cluster can't process enough traffic anymore if the issue custom field, which provides from the custom field, are slow to generate. So basically, you create the custom field, which takes 800 milliseconds to produce the value because you want to compute or because you want to talk somewhere or something else, and the throughput of the cluster reduced from 1,000 operations per second to 50. And that's it. That kills the cluster. That's why the performance part of this is very important for scalability of the cluster. So how it will look like? It will look like a node can keep up with replication. That basically will mean that nodes start slowly drifting away from each other, and you don't talk to the application itself, it talks to the set of nodes which have different data. It will include all the problems which we discussed before, because it's same node, same replication. But at the same time, it have extra nodes. First of all, since it's a single threaded replication, that means something which was not very painful and single node, like, okay, it's one user having one problem with one custom field. Now when it's replicated, it becomes sequential, and this start slowing down the whole replication queue. So your app will slow down the whole DC. Feels a bit scary, but it is like it is. Another part, please remember, is that this is write amplification. If you decided to increase the size of the custom field values just twice, per node is not a big deal, right? You're storing 100 kilobytes, suddenly start storing 200 kilobytes. If you have 4 nodes cluster, amplification will be 8 times, because you start storing the same data per node everywhere. That's something to keep in mind. And one more thing is which we see quite often is that people try to, when the nodes can't keep up with replication, they try to add more nodes. It doesn't help. It's basically doesn't help at all, because node already can't keep up. Adding more nodes is not adding the extra compute power. You need to fix the custom fields, and that helps the cluster. The best practice here is that to store values, because in the cluster, you storing the values will avoid the recompute. One node computes the values, stores in database, another node just picks up the value from database. Cheap, no problem at all. Test with 3+ node. Why 3+? I can share an example from my university. When I was studying the linear algebra, my professor was saying, well, 5 dimensions is easy. Right? You start with 3 and add 1 dimension, think about 4-dimensional space, and then start thinking about 5-dimensional space. It should be easy. The same goes with the DC here, is that going to more nodes starting from 3 have a different behavior of the cluster. Because when you have 2 nodes, there's not much traffic going on. Just 1 node sends message to another. 3 nodes, 5 nodes, the hash computation between the nodes and hash traffic exchange between the nodes way higher. So having 3+ nodes is a major difference having just 2 nodes. 4 nodes, way better. And the last part is that if you believe that you produce the custom fields or you compute the custom field values in a way that you depend on something else, or you don't trust the way the data might be coming from, please help end users, Jira admins in this case, and give them a way to understand the time. So then they can understand if slowness of the issue, like overall is 30 seconds, and you specifically say, hey guys, it's me 20 seconds doing this. So it's clear what is going on. They might accept this. At least there will be no frustration and will not spend weeks understanding what is going on by enabling debugger on live production. So if there's a way to do this, please measure yourself and report this back to the Jira admins so they understand what is going on. There's a couple of things which I think me and Mel spent some time to understand how we name things. And there's a couple of overall hard things to do, right? Cache invalidation and naming things. And then we spend a lot of time also to understand the name of the project. In the Forge project, which we just launched, it spent some time before we found the name. So that's naming. There's another part which is also hard, is cache invalidation. Why I want to talk about that, because when caches are not properly done, Jira search is not consistent. So the performance could be fine. Replication is fine, all awesome. The problem is that you talk to different nodes, you get different results. Again, confusing. So usually this happens because of the two things. Node collects data in different time, or errors in reindexing. I will talk about the last one. It's easier. So you replicate the message supposed to be reindexed and supposed to be done. There's exception during this somewhere, and then basically the new Lucene document was not created. We use the same old document. That's why nodes doesn't have the old data. The value at different time, it's a bit more complex, especially it's relevant to when you compute the data. So very often, when you calculate the data at node 1, you have one situation about environment when you live in. You might have certain custom fields around you. You might have certain issues around you. For example, issue A computes data from issue B and copy the value multiplied by 2. To the moment when this event propagates to node 2, issue B was modified. And now the same issue A has a different value. It was 100, now it's 200. So the data goes, different data into the database, and different data goes into the scene. That will be super confusing because from user perspective, they run GQL and one node shows the value, another node doesn't show the value. The assumption here is that when you compute those values, think about that. Sometimes it's important to have those differences. You want to have as late data as possible, but sometimes you need to sacrifice that because you want to have consistency. So you will use the value with specific TTL, for example. Or another example for this could be stale cache. When you assume that the data is up to date, you reuse it, and you don't update the cache ever, and then suddenly your results are basically stale forever. Those two examples of this cache. Another example of having GQL inconsistent is more like a bug. So when you leak in the searchers for thread locals, you keep pointer in time to specific instance of the Lucene reader. And it's fine for your thread. You have this pointer. You move away. Then another executor comes in, and they reuse the same context. And they see the data point in time snapshot. And it feels like data is not consistent just because you're reading the data from somewhere way behind in the past from the Lucene comparing to the other data. And this example also I wanted to mention, sometimes replication from Jira is not enough. Sometimes you don't want to piggyback anymore on the replication of the issues. You want to have your own replication. Maybe you have your own data processing, something like this. And a couple examples for you. So you can use cache to replicate events. But in this, make sure you use the short-lived object because there's no persistency there. So if you are fine with that, go ahead. One thing also, if you have a lot of big objects, try to avoid use the cache because cache will have full mesh computation. The more nodes, the more communication. So in some cases, it will be way better, especially for bigger documents, for bigger objects, just store the data in database. And then having more nodes, if you go to 20 nodes, you have just 20 reads. It's way cheaper than have the full mesh communication. Sometimes you want to use the your own Lucene, you can do it. If you have a need for that, and I know some vendors already doing this, just go ahead and do it. If you want to have persistency, you might want to create your own replication queue from scratch. Currently, Jira doesn't provide you API for that. There's no inbuilt techniques to use the same. You can just copy the idea from the replication from issue. It works reliably, so you can just basically, that's why I mentioned your tables. You can just copy paste the same tables into your own application and it should be fine. Thinking about this, don't use cache for consistency because you might miss the events when the node is down. So you might use the replication queue for the synchronization points periodically and the cache for the small events. It's one of the ways. And try to avoid use cluster message mechanism for heavy traffic because it, again, doesn't provide you consistency, but also it was not created to have heavy messages. It's mostly like for small messages. Not joining the cluster or UPM changes, something like this. And since you are going to create your own replication, please think about monitoring and health checks because we have those things as part of the product, and it really helps Jira admins to understand when things are working or not working. But then it's also important to have it as part of your product. Couple of things as a takeaways for you, and then we'll have a slide this later. You can take a picture. This is the KB articles, which explains how we troubleshoot, some of the REST APIs and data which you can use. So those things you can keep in mind. And also, it's part of the Jira itself, out of the box. There's a cluster index replication health check. So to recap, main takeaways. So I wanted to share with you inside how the DC replication works. I think we covered that. I wanted to explain how DC apps can be causing the downtime of the cluster and can be causing index replication problems, specifically with the test data. I think we covered that. And again, please use bigger data sets, more nodes, and try to use the recommendations which I mentioned to you to make sure the application is stable and scalable. That's what I wanted to talk today. We have like 2-3 minutes for questions. If you want, you can catch me later. Thank you very much.
Thanks so much, Andriy. Do we have any questions?
Thanks for the talk, Andriy. Question for you. How often is it that it's third-party apps that are instantiating re-indexing jobs? And is there any way to know if there's already a whole bunch of re-indexing jobs in a queue or if one's active to not actually initiate a new one?
Yes, so there's API for that, which I mentioned one of the keybs. You can monitor that, and you'll see the current status of the queue, and then you'll see the events. You can see how many nodes are drifting away. That's one way, and then you can monitor the table directly. You can understand that. If there's a job which is initiated and still running, it's not visible anywhere. You will need to just pull the UI. That's only the place.
All right, we've probably got time for one more question. Anyone?
I start by saying I've never touched cloud, but we all know what does it mean for Atlassian for last years. So I've worked on a big project that, for performance reasons, had to implement a custom indexer and so on data center.
Yeah.
How do you see the same performance concern for searching issues, big data sets of issue in the cloud as related to data center?
Let me step back. All I talked was only about DC. It's nothing to do with the cloud. And in the cloud, there's no Lucene right now.
The cloud was?
In the cloud, currently there's no Lucene.
Of course. So if I had performance issues on the cloud that in DC I may solve by indexing.
I would say if you follow the recommendation and you store enough data in the DC and in the Lucene, you will not have any performance problem. Normally, the search is super fast. Lucene is a very good library, especially right now with Jira 8.5. We're upgraded to Lucene 7. The speed increased around 20-30%. The size decreased around, again, 20-30%. It's way better. Welcome.
Okay, great. Well, thank you so much, Andriy, again.
Thank you.